Hey everybody, it's Derek at MillRight CNC. I'm going to show you how to take this chunk of maple and turn it into this baseball bat using the Mega V2 with a 4th axis. So we have the vacuum bed on this Mega V2 XXL. So I've laid down a sheet of MDF that I was doing work on before. I used that to screw down my 4th axis headstock and tailstock. The tailstock's independent, so I can slide it back and forth to get the workpiece in and out if I'm making multiples of the same part like I am now. So the chuck will take up to 2.75 inch outside diameter, which is roughly what this is. So next I'll show you how to chuck it up in the machine and how to pick up your zeros. So there are 2 sets of jaws that come with our chuck. I've got the second set of jaws that's going to be able to clamp OD a little bigger than the first set of jaws, up to 2.75 inches. So I've got them spread out to where I need them. You've got to be careful that you don't unwind the chuck jaws too much. If you do, these are going to pop out, and then you've got to make sure that they're recentering. But I've got them right where I need to be. First I'm going to slide the headstock of it in and just get it kind of clamped to hold it there. Next, I'll move over the tailstock side. Notice I have an imperfection in the blank of wood here. That's not where I want to clamp. So I'm going to get that between jaws, and I'm going to slide right up to it. If I need to, I'll open up the chuck a little bit. From here I'm going to press into the head chuck. Just get a little tension there. I still want to be able to press it all the way up against the head chuck. So now I'll move back over. I'll give it some pressure here. Again, I just barely clamped it just to kind of hold it in place. I'm just going to turn this chuck. You can only turn this if the motor's off. This planetary gearbox combined with the motor is going to generate a lot of torque. Don't try and over torque the motor. Don't try and defeat the holding torque of the motor to move it. So shut it off. Just hit the E-stop on the box so you can move it where you need to. I'm looking here. I don't have any imperfections or divots in the stock clamp, so this is where I want it. I've got it up against the jaws here, and I'm just going to give it a good tighten here. I'll come back to the other side, I'll do the same thing, and now I'll show you how to pick up the zeros. To pick up my zeros, I'm going to use this chuck carrier plate. I know certain things about its measurements, and you should too. I know that the center line of the chuck is 42.5 millimeters from this surface, and it's 40 millimeters from this surface or this surface in this direction or in that direction. So the way I have this chuck set up, the workpiece is going in the X direction. So I'm going to pick up my Y, and I know that when I'm at the edge of this piece that I am 40 millimeters from the center line. So how am I going to do that? I'm going to use a machinist grade Post-it note. We're going to be selling these in the store for $19.99. Pick up 4 or 5 of them. So you're going to take any Post-it note that you'll get for cheap. You're going to put this down here, and you're going to jog the machine very slowly using a very low step size and a low feed rate until you pinch with the end mill between the end mill itself and the side of this plate. So do it very slowly. You're just looking for a little bit of drag here. Once I do that, I know that I am 40 millimeters plus the radius of the end mill plus the thickness of the Post-it note from being on the center line here in the Y direction. On the machine, the way I have this set up right now, this is Y positive, this is Y negative, that's X positive, and that's X negative. So when it's all said and done and I've pinched this, I'm going to be 40 millimeters plus the radius plus the thickness of this from my Y0. So that would actually be, because this is a 1/4 inch end mill, 6.35. You half it to get the radius, so that's 3.175 plus the thickness of this, which is about 0.08 millimeters, plus how far the edge of that is from the center line. You do the math, we'll put it on the screen. I'm not smart enough, and that's going to be your position. Next, I'll show you how to set the Z. So now that I have my X position already set, I'm going to pick up the Z. As I mentioned, the center line of the chuck this way is 42.5 millimeters from the top of this piece here. So I'm going to just take this post-it note here, and I'm going to jog down until I pinch. I'm just using a very small jog, and I'll move it back and forth. Just very minutely moving the Z here. There we go. And I've got a pinch. Okay, I'm pinching there. Maybe I'm even a little over pinch. I'm going to come up just a little bit. There we go. I'm dragging the paper. I'm tearing it a little bit. I'm right where I need to be. I wouldn't want to go any further than that. So I know now that I'm 42.5 millimeters from here, plus the thickness of this paper that I've pinched right down here. The paper's about 0.08 millimeters, so I'm 42.58 millimeters in Z positive above the center line here. So if I'm trying to set that as my G54 work position in a Gerbil system, I would just type in G10 L20 P1 Z 42.58, and then that will set the Z0 right down here. It's important that you know how you're setting your work coordinate origin relative to what you have set up in CAM. If you have the CAM set up so that you've got the top of the stock as your Z0, it's not going to work out very well for you. Be even worse the other way. So make sure that you're being consistent between what you've done on the CAM side and what you're doing picking up your work coordinate. All right, so we're done with that. We're going to zoom in a second. You're going to get to see how smooth the bat is. If I could do a couple things differently, I probably would rough a little bit slower. It's something I actually meant to change from the last file and just forgot to do. But I definitely could have taken a bigger step over. You're going to see just how smooth this is. I could have left a little more scallop on it by stepping over faster, and the project would have finished faster, and I would have had to do a little more sanding. At this point, if it's anything like the other bat, I'm going to take a piece of 320 I'm just going to run it down the length of the bat for about 60 seconds, and I'm going to be where I need to stain it, put some oil on it, put some poly, whatever you want to do. So let's check out the bat. All right, so I have a look at the bat. As you can see, there's very little scallop. It's just going to take a little bit of sanding here to get it just where we need to be. Everything came out perfect as far as I'm concerned. What we may do here is laser engrave it. We'll see if that's a project for another day perhaps. We may go ahead and mount up one of our JTech lasers right here to the router head and maybe engrave something cool in it, the MillRight logo, something like that. Let me show you how we would check this out. So I'll start over here on the head chuck. I'll just loosen that. I need to come over here to the tail chuck. I loosen it. From here I can slide that out of the way, slide that, and I've got my bat loose. Came out pretty nice. What we'll do from here is I'm going to go over to my bandsaw and I'm going to chop right here to get rid of this block that the chuck was holding on to. I'll do the same thing on the other side, and then I'll just kind of sand that smooth. Like I mentioned, I may chuck it back up and do some kind of engraving. Haven't decided quite how I want to finish it, if I want to leave it natural. But that's the machine. That's the project. It's a fun one to do with the 4th axis. You're going to make something cool for your kids, make something cool for yourself. If you got a kid that plays ball, it'd be cool if he was out practicing in the yard with something Dad made for him. If you're into that, give it a shot. Let's got the other side down now. It's clamped in here. I'm going to support this side as I cut it. There we go. I've got a little bit I need to cut off, or sand off rather. But there's our bat. Now we got to do a little bit of sanding here to get the ends just like we need it. Just make that surface smooth. We'll figure out how we want to stain it. I think we may go dark on this one since we were light on the other. For the ends, I used 120 just to knock down where we were a little rough from cutting on the bandsaw. And then for the length of the bat, I'm just going to run some 320 down it a few times. And the machine cuts smooth enough, and that's really about all it needs to be ready to stain. All right, I'm just going to use some pre-stain conditioner here just to make sure that I get a good even application of the stain. It's not blotchy. I'm really not an expert on wood finishing. I just like to cut stuff. But this project just seems appropriate. The last one I did come out a little bit blotchy. The maple's pretty porous. And actually had my kid helping me out with staining that bat. And probably didn't give him enough instruction on spreading it out evenly. That was my fault. But I think with this free stain conditioner, when we put that stain over, we're just going to have a lot better result in terms of it not being blotchy. Leave me some tips in the comments. Again, I'm no better at wood finishing than any of you guys. I'm just a CNC guy. We'll get a coat of this on. I'll let it dry however long the instructions tell me to let it dry. And then we'll put on the stain. Alright, so I've let the pre-stain conditioner dry up a little bit. I'm going to take some stain here. This is Jacobian or Jacobine. We've had a little debate on what it's actually called. Let us know in the comments what it's actually called. Alright, so blot that a little bit. Just start rubbing that in the grain. Yeah, I'm really liking how that's looking there. Now we got a little thick on that initial pass, so I'm just going to rub that, try and get some of that excess off. It gives kind of like a rustic look. I like that. Just like an old bat. Okay. All right, we'll finish this up. and then we'll show you how it turns out. Maybe go hit a ball with it. Hey everybody, it's Derek at MillRight here. I'm going to show you a little bit of the CAD and CAM side of the baseball bat that we made. I'm in Vectric Aspire right now. You could also use Vectric VCarve to perform the same function. This file I actually got on the Vectric forum. If you just Google like Vectric baseball bat file, I'm not sure exactly what term I used, but I found it on the Vectric forum. Some user in the past had graciously posted it there. I think it even had the toolpath, so it gives you a real head start if you're new to doing this. And even if you're experienced, it's going to save you some time. When you're setting up a rotary job, just a couple clues on how you would do something similar to this. A few things that you need. So you're going to set the job type as rotary. Here I'm defining the length of my stock, the diameter of my stock. I showed you out on the machine that I like to use the cylinder axis as my Z0 position. And I showed you, given our particular fourth axis bearing carrier, how you would pick up that Z position. Showed you how I'd pick up the X position, or excuse me, the Y position if it's oriented in the X, and vice versa. Basically, the center line of the chuck. I've got it oriented along the X axis, so I'll click OK there. Now, when I want to machine like a swept profile or a spun profile, I need a couple of things here. I need this drive rail that tells it where to start machining that, and I need half of the profile that I want to cut. So this is just a mirror image of, if I split this in half, it's just half the profile, right? This is going to be, again, where I want it to start machining. And what I've done here is I created a line, just a vertical line that's 8.6394 inches tall. Why did I do that? If you'll remember back over there in my job setup, the diameter of the job is 2.75, and this figure here is just the diameter, 2.75 times pi. So that gives you the circumference of that stock. So a 2.75 inch diameter piece of stock has a circumference of 8.6394. That's why I put that there. So when I come over to my toolpath, there's a little gotcha here where if you don't have that clicked, you're going to try and calculate the toolpath and nothing's created. You get this error message that isn't necessarily informative. If you're getting that, it's probably because you're not selecting a drive rail that tells it where to start. So I'll click that, and then I'm going to hold the shift button, and I'm going to click my profile that I want to machine. I'll tell it to calculate, and I will get my toolpaths. All right. Take note, again, I can't emphasize enough that this is where, I'm going to uncheck this so we can look at just the line. This is where it's going to start machining. So this is X0, so it's going to start machining somewhere around like X6 point or 0.62. All right. I did that just in case I forgot exactly how I set it up, and I ended up setting my X position a little too close to the chuck. I knew the bat was like 32 and a half, 33 inches long, and the entire piece of stock was 38. So I knew if I came a little bit off the chuck here, I would be good and I would avoid it. If you would put this, say, like way over here, all right, and then you set your X0 right outside the head chuck jaws, well, it's going to come over here and start doing machining. So make sure that this drive rail is set somewhere either at the zero position or a little bit to the right of it, but not so far that you're going to be into the other side of your chuck or tailstock or whatever you're using to hold the other side of your workpiece. So again, I'll come to edit. I've selected this. I'm going to hold shift. I'm going to select my profile. I calculate it. I get my toolpath. Something to take note of. You just might want to look in here and make sure that it's not running toolpaths all the way to the center of the diameter. If it were, then your piece is going to cut loose from your chuck entirely. And that's going to end up with a ruined piece, right? Something's going to go flying. So make sure that when it establishes those toolpaths that you've got this hollow in the center of the toolpaths that are projected here onto the screen, to know that you're not going to cut all the way through your workpiece. So when I'm ready to save my profile, or save my toolpath rather, I'm just going to go here to save toolpaths. I've got a machine set up, the MegaV Pro. You could set up other machines, but I've just got different post processors that I work with on the MegaV Pro. I happen to use the same post processor here for my work on a Gerbil based machine. That's the non-pro MegaVs. So I'm going to use G-code wrap Y to A millimeters. Now there's a specific reason I'm going to use millimeters. That's because Gerbil normally works in millimeters. So unless you've configured things differently, you get the machine, you get it together, you start using it. All the jog commands are in millimeters. So it's in the context of G21. If you know G codes, G21 says, hey, every motion command after this is in millimeters. G20 says, hey, every motion command after this is in inches. Well, this particular post processor does not put a G20 for the inch one or a G21 for the millimeters at the top of your code. So let's say you've set your Z0 as the cylinder axis, and then the first movement is a movement to Z 2.5. Well, that's going to be somewhere around here if you're in inches, and somewhere about right here if you're in millimeters. So it's just going to plunge right into the stock. So I think rather than having to remember to put that G20 or G21 at the top of the program, or making sure that you put it into it before you put it into the console before you run the job, I'll just say, hey, it's running millimeters. That's what I'm going to do. I save the tool path, I take it out of the machine, then I run it. You guys have seen that, but this was just a little background on how you go about creating the tool path for a rotary job. Thanks.